Okay, section 3 of chapter 10, geometric sequences and series, just like section 2 was arithmetic sequences and series. The series will still be the summation or adding up of the terms of a sequence. The formula to find the nth term of a geometric sequence would be a sub n, the nth term, equals a sub 1, the first term, times r, the common ratio, right? We use d for the common difference in arithmetic. Geometric, it's a ratio, to the n minus 1 power, where n is the number of terms. A sub n is the nth term, the number of the term that you're finding. So if you're trying to find the 82nd term, you'd put a sub 87, or 82nd, 82, and then 82 minus 1 would be to the 81st power. Okay, so there, in example 1, there is an email situation at the top of page 674. We'll take a look at that. Julian sees a new band at a concert. He emails a link for the band's website to 5 of his friends. They each forward the link to 5 of their friends. The link is forwarded again following the same pattern. So the pattern is multiply by 5 each time in just some random situation here. How many people will receive the emails on the 8th round of emails? Right? And example 1 is, if the pattern continues, how many emails will be sent in the 8th round? So let's go back and look at what we'll do here. How many in the 8th round? So the 8th round is 8. N equals 8. So 8 minus 1 is going to give 7 here and 8 there. So a sub 8 times a sub 1. What's the first term? He sent the email was sent to 5 different people. So the first term is black, 5. So what is r? It's times 5. 5 to the 8 minus 1. 8 minus 1 is 7. 5 to the 7th is 78,125. Times 5 is 390,625. Okay. So the pattern. Okay. All right. Here's what I just thought of. So the pattern is not one person sent one email, and then in the second term there's 5. 5 emails sent. 5 emails sent. The pattern is starting at the first, I guess I should use, the proper term is iteration, the first iteration of the pattern, the first number. Just having a hard time remembering a good common definition for the word iteration. Iteration is the first time it happens. It happens times 5, so actually the first term is the 5. Not the 1. Okay? So 390,625 emails sent in the 8th round. Example 2, write the nth term equation. So you're coming up with the equation, just the equation for the nth term. So we don't know what a sub n is. All right, but we know that the sequence is 0.5, 2, 8, and 32. Right? So it's, how do you get from 0.5 to 2? How do you get from 2 to 8? How do you get from 8 to 34? These 3 numbers help you more. It's times 4, it's times 4. So then you look and see, is 0.5 times 4 2? Yes, it is. Pattern's 4.4. Otherwise, you'd use the ratio of 32 over 8 is 4. 8 over 2 is 4. 2 over 0.5 is 4, so the common ratio is 4. So the first term is the 0.5 there, filled in for the first term. R is 4. We don't know the nth term, that's just finding the equation. If you were asked now to find the 63rd term, you would plug in a sub 63, you plug in 63 minus 1, and it would be 4 to the 62nd times 0.5. And B, given different information, if you're given a sub 4, the 4th term is 5 and r is 6. First find a sub 1. Right? There are two ways to go about this. Find a sub 1, we know a sub 4. We also know that r is 6. So over here, using the formula, we know that the 4th term is 5. So we know that a sub 4 is the 4th term, and it's 5. We also know the common difference is 6, but what we don't know is a sub 1. So first you need to find a sub 1. So 4 minus 1 is 3, 6 to the third is 216. So then you divide both sides by 216, and a sub 1 is 5 over 216. Okay? The other way that I looked at, the more common sense way of how to find the first term, is if you know the fourth term is 5 and you know that r is 6, 5 times 6 is 30, that would give you the fifth term, but going backwards, you divide by 6. So divide by 6 will give you the previous term. So a sub 3 is the 5 divided by 6. A sub 2 is the 5/6. Also divide by 6 again. Divide by 6, we already have a fraction, so it's multiplying by 1/6, 5/36. A sub 1 is the 5/36 divided by 6. So you multiply by 1/6 and it's 5 over 216, which is the same thing as this. So it's two different ways to look at how to find a sub 1. So now that you know a sub 1, what are you being asked to do again? Write the nth term equation. Okay? So nth term equation, we found a sub 1, so then a sub n equals a sub 1 r n minus 1. We were told that r is 4, so a sub n is, what number are you finding? A sub 1 is 5 over 216, 4, n minus 1. We don't know n, so we can't know n here. We're just finding the equation that if we're given an n, you can find that term. All right, example 3, the geometric mean. Just like the arithmetic mean, the geometric mean, it means to find the missing terms between a first term and an end term of a sequence. So you got to find the 3 missing terms, and basically what do you need? You need the common ratio. So find r. How do we find the common ratio? We need that r is the common ratio. So the formula a sub n equals a sub 1 r n minus 1. Okay, so first we know that the first term is 2. We know that the first term is 2, so a sub 1 is 2. Right? And then we know that the second, third, fourth, fifth term, the fifth term, a sub 5, is 1,250. A sub 5 is 1,250. So we're going to leave r as the only unknown. So 5 minus 1 is 4. Divide both sides by 2 to get rid of the 2 and get the r to the fourth by itself. So 625 equals r to the fourth. How do you solve for r to the fourth? You take the fourth root. The fourth root cancels out the 4. The fourth root of 625 is 5. So r is 5. No fill in the missing terms. I think there's a mistake there. Now fill in the missing terms. So times 5 is 25. Times 5 is 125. Times 5 is 625. And times 5 is 1250. Times 2 is 1250. I will have to take a look at that, and I don't want to take up video time to take a look at that. I don't want to start over at this point. So I will take a look at that and let you know in class what happened there. Geometric series, the sum of the terms of a geometric series. Geometric series is the sum of the terms of a geometric sequence. There are 2 formulas that you can use. All right, the formulas are plug-in. You just have to know and use the formulas. So there's only 3 sections, but there's a bunch of formulas. So you're gonna have to know these formulas for the test on these 3 sections. Okay, it's not gonna be a quiz because it's what we're doing for the whole chapter, so it is gonna be a test grade. All right, so a test grade counts much higher than a quiz grade, so make sure you know your formulas, study them, okay? In honors, the 4th marking period is no excuse for getting lazy or not continuing to improve. So you have 2 formulas there. Both of them have a stipulation that r cannot equal 1 because that would cause the denominator, which is the same in both, to be 0, and you cannot have a denominator of 0. All right, both of those formulas. The difference in the formula is a sub 1 times r to the nth. This is a sub n times r. From example 1, right, the total 8 rounds of emails, a sub 1 is 5, r is 5, and n is 8. It's 8 terms. The common ratio is 5, and the first term is 5. So what's the summation of the 8 terms? A sub 1 is 5, a sub 1 is 5, r is 5, n is 8, and r is 5. So you just do the math of that. Let's just plug in, and you got to multiply that first, then subtract that, then divide by -4. Negative over negative is positive. So there are a total of 488,280 emails sent in those 8 rounds of emails. Just 8 rounds of emails. All right, very big numbers. Sigma notation is the same thing as it was for arithmetic sequences. So if you didn't get it then, maybe you'll get it now, and it'll make more sense back with arithmetic sequences. So f of k, the base is r, 4 times 2 to the k minus 1 would be in the example. So find. This is the example, sorry. So you're plugging in 3 for k, and then you're plugging in 4, and you're plugging in 5, and you're plugging in 6, and you're plugging in 7, 8, 9, 10. So you're plugging in 3, 4, 5, 6, 7, 8, 9, 10. You're plugging in, there's 8 terms. All right, so n equals 8. So there are, and I figured out here, 8 terms because it's 10 minus 3 plus 1. When you do the subtraction, you lose one of those. When you count by your fingers and include 3 and include 10, you get 8. So there's 8 terms. So a sub 1 is 4 times 2 to the 3 minus 1. All right, so you're finding the summation of these terms. The first term, I think I have some missing information here. Okay. A sub 1. All right, so we need a sub 1. And, okay, so here we go. This is what I was looking for. All right, I knew I had that in there. We're going to use one of the 2 formulas still, just like in arithmetic sequences. But you need some information. So plugging in 3 for k, right? Plugging in 3 for k, this is the given equation, the given function. Plugging in 3 for k, you find out that a sub 1 is 16. So the first term is 16. Okay, so a sub 1 minus a sub 1 r to the n over 1 minus r. 16 is a sub 1. 16 is a sub 1. R is 2. That was a given. N is, we know, 8 terms from above. R is 2. Right? R and R. 1 minus 2 is -1. So 16 minus 16 times 256 over n minus 1 is -16 minus 4096 over -1. -4080 minus over -1 is positive 4080 as a total. Okay, the classwork homework is page 678, number 19 to 53 odd, and skip number 41.